Just wanted to start this video off by sharing some of the design stages of this project. So here I am in some online design software. You can use this stuff free. I've got a brown piece there that is representing the fence post. I've just pulled down a part that I've designed, which is the solar panel. The next part that was created was this enclosure shown in orange. It has the slot for the solar panel to fit into. That fits onto the fence post. Up there I have the model of the PRI sensor I'm going to use. So I've just dragged that down into place. That has all the holes and the variable resistors on it. Just dragged down the LED module there, the component that's going to hold the LEDs. The other thing that I need to insert into here somewhere is this battery, this 18650 cell that I'm going to use, and I actually grabbed a holder that is going to be inserted in there, grafted in, and then finally the bottom plate, which has been dragged down, just shows that all the parts fit together, fit in the plate, and then the final part that I can do there, I'll have a little look around them, and then I believe I will just drag them up into place. There we go, slot them in. That's the final assembly there. And then the last thing I can do is actually just convert that into a hole or a see-through component, and I can just check that everything fits in there, that there's no interference between them. That allows me to put everything together and know that it's going to function or fit together in the real world. So it's just the process of 3D printing those components. It's only the 3 components that need printing, so the top half of the case, the bottom half of the case, and the little component for the LEDs. Now there is a couple of other components that I haven't covered. We will definitely need some sort of transistor to power our LEDs. So I do believe the output from this device here is just a couple of milliamps at the most, I think. Again, look at the data sheet, I'm going off memory here. So that pin, when it goes high, is not enough to run the LEDs. I think it barely lights one of the LEDs. So what I'll actually use is this little transistor here. I've got a I think BCX38C. They can switch up to 60 volts at 800 milliamps. A NPN type. I always remember that it will switch on with the positive in the middle. And that's of course not the pin layout, and in a bit we'll have a quick look at the pin layouts, but that's the transistor we'll use. We'll use that to switch those LEDs on and off. The other thing we'll need is some sort of power resistor to actually take some of the power away from the LEDs. As I say, I just want to drop that voltage. Now I did a little bit of calculation using an online calculator, just a bit of Ohm's law. I'm guesstimating about a 10 ohm resistor. It's not exactly what it should be. I think it's meant to be a 22 ohm. I don't have a 22 ohm in stock. I will just run a 10 ohm at the risk of the LEDs dying at a younger life. Again, this system isn't designed to be switched on all the time. It will just switch on and off for a couple of minutes as and when needed. I'm going to use a small bit of Veriboard here just to mount this onto, and then what I'll have to do is create a little circuit using a soldering iron that takes the voltage, the output from this PIR, passive infrared sensor, switches on the transistor, power will go out through the power resistor and into the LEDs, which will be connected up in parallel, so they'll all be getting the same voltage. If there's any imbalances in these cheap LEDs, that does risk burning them out at a younger life. Now, is this a burnt out one? No, that looks alright. I thought I'd seen a burnt out one there. I've burnt a few of these LEDs out And when they're burnt out, you'll see sometimes there's a little black bit inside. They physically have a little burnt bit inside the LED. Let's see if I can demonstrate that to you. So again, if you're trying this at home, be aware that LEDs can explode when you overvoltage them. They can literally go bang and blow themselves to bits. So I'm just going to close my eyes while I do this and see what happens. There you go. So I think you saw it burn out there. And actually, if we look, no, I can't see any evidence that one's burnt out at all. Okay, but sometimes you're looking there, you'll see a little burnt black piece, but not in this case. That's a really bad example. Never mind. Carry on. What's some of the other things we're going to use? Well, you can never have enough screws, so I like to keep a little box of little screws. We're just going to use some of the smallest screws here, and I'll start actually assembling some of these bits. So I've already inserted the battery. I'll probably use a bit of hot glue each side of that. I could put springs in there, but I don't want to waste springs. It's not going to go in and out, it's in there to stay. The other reason I'm using these 18650s is they've been sat around in a metal tin for a long time. I always cover the ends up because you don't want to short them, but I am getting a bit worried that they're going to burst into fire at some point. So what's the best thing I can do with them? Well, I thought I'd just put them outside in the garden. If they catch on fire, they catch on fire. Hopefully they won't burn the whole garden down. So I'll just screw that in. You'll see that the hole is just the right size. The feet are in just the right place. If you're designing your own, that might take 2 or 3 attempts to actually get that exactly right. I've 3D printed my casing. I guess you could find any kind of case to put this stuff in, a wooden case, acrylic case, anything you can get hold of that might take these parts. You could hot glue them. Got a hole there, of course, be careful if you're cutting holes. The other idea is that bit will go in there, and that bit will tilt forwards and backwards. I'll just show you the construction of one of these LED modules now. We're going to need some hot glue, useful battery powered hot glue gun. Going to need an electric drill with a 5mm drill bit. I just had to clear out these holes in this module here. If you've done a good job, you might not need to do that, but I've had to drill them out to get my LEDs to fit. The other thing we're going to need is some form of soldering iron. I'm going to use a gas soldering iron here, but electric one will be fine. Wouldn't mind one of those rechargeable ones, but I'm going to stick with a traditional flame type iron at the moment. Going to need some solder. Going to cut that off up here. There we go, bit of solder. Probably need some cutters, very useful, and of course our LEDs. So I'm just going to start off checking that's hot, and that is hot, and it is burning. Get that off my fingers. Ouch. Don't worry, I'm okay. I'm going to make sure I get the polarity correct on the LEDs. The last thing you want to do is solder them in and find you've got one backwards. So lining them up here, checking that either the flat edge of the LED is going to be the same way, which is negative, or the shorter leg, I believe. Get the iron going, rev it up, drop it down, bring it back on. It's heating, nice. Be careful, that's very hot. Pop that up there. So first thing I'm going to do is just squidge some hot glue into the holes. 1, 2, 3. Job's a good one. Take my LEDs and whacky in there. Whack 1 in, whack 2 in, and whack the 3rd one in. So just let those start to set a little bit. I'm going to press down the neutral or the negative terminal legs inwards to the 3rd leg in the middle, trim them up so that they don't have any excess leg on. There we go, never want excess leg, that's the worst thing you can have. You can hear some building going on in the other room. Okay, I'm going to bend the positive legs down. I'm going to bend them all up because I'm going to get them to go up and around the outside. Trim them off, line them up, and then Hopefully by now the iron's up to temperature. Let's check that. It melts, it's hot. Good. So the next thing we're going to do is actually solder these terminals up. So we're going to solder the neutral legs, and then we're going to solder the positive legs. Neutral legs are called cathode, positive ones are anodes, but not many people use that kind of language anymore, even though it is the correct terminology. So here we go. Line up the next 3 LEDs that are going in. Squirt a bit more hot glue in. Oh, hot glue stick fell out. 1, 2, 3. Pretty easy, pretty simple. Bit crude, but never mind. 1. Check that polarity. 2. Check that polarity. 3. And I'm just going to do exactly the same process here. All the anodes pointing to the left there. They'll meet up at the other end with the other anodes. Get rid of that excess leg. No one likes excess leg, do they? Maybe they do. Solder that one down. Don't worry about the smoke coming off here. You can probably hear a fan running. Maybe you can't, but that is the extraction system going. A fan and a filter. Also have the window wide open, let the fresh air in. Here's also lead-free solder with a friendly rosin. Friendly rosin that's good for you, I believe, or lack of it. Something like that. Some magic that makes the solder flow. Trim those off. Oh, bit fiddly. Never mind. Oh, it's stuck to me. Hot glue. You've got to love hot glue. Gets everywhere. There's the right time and the right place for hot glue. Surprising where they use it. Solder those together. And trim the excess leg. Whoa. Can't really see the trimming of the excess leg, but that's what's happened. There's no other magic going on there. We're just trimming them off. See, there's the proof. Solder that up. So now I have 6 LEDs connected in parallel. Just double check the soldering there. Good. Now that's pretty much it. LEDs are all in. I'm going to leave the iron running. I've got a couple other bits to go on here yet, so we're going to solder this power resistor on. Bring the leg up. How much leg do we need? About that much. Trim it off. Excellent. I will tin the components. We just get their legs wet. That's it. Get a bit of solder on them. It helps. Makes things easier. Bring the iron down. Bish bash bosh. Soldered. One more for luck. Why not? There we go. We'll put it down on its stand, the old soldering iron. Quite hot. Could set fire to the surface there. So the next thing I'm going to need is a couple of fly leads or bits of wire. I've got some purple and yellow. It's what I've got in stock. Should always use wires that are easy to identify between positive and negative. The traditional red being positive and black being negative, but in this case I'm going purple negative, yellow positive. That is my own colour coding that I know. Good luck if you want to backwards engineer one of these when they find them in the future and they're wondering, what is this technology? What do these colours mean? But there we go. We're just soldering that one into place. And that looks like it's lovely jubbly. Yes, great. So I think that's it there. Pretty much done with the soldering. Can put that down, turn it right up and then off. I've got to trim a bit of excess leg off that one. And then we're going to finally strip some wire off. Going to pinch the end, wrap. There we go. Good technique I like. Gently pinch on the end, wrap it around your finger and pull. Don't pull too hard, don't drop your finger off, but that should be adequate to strip those wires bare. Just going to crank the power supply up now. do a bit of final testing on this module. Want to make sure it works before we fix it in, glue it in, stick it in, make it difficult to work on. So red to yellow and purple to black, and the module is on. Brilliant. So we've got all the LEDs lit up, functioning fine. Going to do some final bench testing here. So at 4 volts or 3.97, you can see it's taking 112 milliamps. Perfect, nothing to worry about. Crank the voltage up and down a bit. As I crank the voltage up, I can see it's not going dimmer, so I'm not overpowering this module at about 7 volts. And if I drop it right down, you can see it's still adequately lit at some very low voltages there, about 2.4 volts. That's fine. And if I drop it a little bit lower, I can actually see it shuts down at about 2.16 volts. A lot lower than the lithium polymer should go, but should be enough to protect the cell from over discharge too much. So very nice, seems to work, no problems at all. So that one is ready to be inserted into this unit. Now, I think I mentioned it could screw into the unit so that we can tilt backwards and forwards. But I don't think I'm going to bother with this prototype, and I'll probably just grab the glue gun. Okay, should be hot enough now. Bloop. 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 It's a bit of a mess, but it's hot. Just for now. I just want the LEDs in there, so there they are. They're in. PIR, LEDs, back of that, and battery. Now what I'll do is I'll just draw a quick diagram of the circuit. As I mentioned, there is a transistor in there as well, so we'll need to connect it up correctly. I don't know how well that will show up on the video, but I'll draw the circuit diagram anyway. So our first thing we've got here is the BC30, what is it, the BXC, yes, BXC 38C. It's a little transistor, 3 legs, and we've got the collector, the base, and the emitter. Now the symbol will be drawn more like so, arrow pointing out, flat piece there, circle round there, and you have your base, you have your collector, and you have your emitter. Now this particular transistor is an NPN type, so you're going to be set up with your load up here, LOAD. Load is going to be connected up to positive, V positive, and that's then going to come down through the transistor like so. That's going to be a collector, emitter, and your base. Now we're also going to have a little 1K current limiting resistor here. Don't really need it, but we're going to have it, and that will come down to your 0 volts like so. So, oh, you didn't really get to see that, but there's a closer look. Okay, so the rest of the circuit is going to include our solar panel. Solar. That is 4.5 volts at 90 milliamps, I believe. That is going to come down negative, positive. We're going to go through a blocking diode. This diode here may be a 1N14001. That's just going to stop the voltage from the battery going back into the panel. There is our battery, plus negative. That's going to come down, is going to power our PIR module, PIR, negative, positive. That's going to go in like so. We've got our output pin here. The output pin is going to go into this 1K resistor, 1K. That is going to have our transistor connected to it. Now that is going to go to negative, so that's that way, and that is going to be connected up to there. Sorry, you might be able to hear a sprinkler system just started up, but I can't really do anything about that at the moment. There is a load here, LOAD, D, and our load is our LEDs. Okay, so the LEDs connect, this side is negative, you've got your transistor here, and positive is up here, so your LEDs are going to be mounted that way. So that's K, that's A, anode, cathode, positive, negative. So that's going to be connected in between there, and we can have as many as these we want. I've got times 6. Okay, remember that the transistor is up to 60 volts or something like that. 60 volts are okay at 800 milliamps. So you can have whatever you want running off there up to 60 volts. Be careful with 60 volts, enough to give you quite a nice shock. And 800 milliamps, anything more than that, transistor is going to get hot and burn out. There we go. And that's the basic circuit there.